everyone, my name is David James, and for today I'll be talking to you about an introduction to EI function. EI function, basically I'll be talking about the origin as well as the assumptions. The rest will be handled by my friend Muhammad Iksan. Now, the origin of EI function, it begins from an unsteady state flow. Now, unsteady state flow is divided into two: radial flow of slightly compressible fluid and radial flow of compressible fluid. But we'll only be looking at this one because we're interested in EI function. And this one is actually further subdivided into two, which is EI function solution and dimensionless pressure solution. But we will not be looking at this, we'll be only looking at EI function solution, which we can use it to measure the pressure at specific radius and time, as well as to measure the bottom hole pressure. Now, EI functions have 5 assumptions. I'm only going to briefly explain all 5 of them. I'm emphasizing on more how to memorize them. Now, the 5 assumptions are it's an infinite acting reservoir, which means that the reservoir radius is very large. The well produces at a constant rate. Thirdly, uniform pressure when the production begins. Fourthly, well-bore radius is centered in a cylindrical reservoir, which basically means that the reservoir shape is they assume it to be cylindrical in shape, and there is no flow across outer boundary. Now, how do you memorize them? I have written this over here, IKUCO. What does it mean? It's because I have highlighted the keywords of all the assumptions. Like I stands for infinite, K is for constant rate because in mathematics K is mostly for constant, U for uniform, C for cylindrical, and O for outer boundary. And with that, IKUCO is it's a simplified version of how you memorize these assumptions. Now I'll be passing it to my friend Muhammad Iksan. Thank you.
Hello everyone, my name is Muhammad Iksan, and today I'll be explaining the EI function. They've already told you the condition when to use the EI function, and now you should know when to use EI function. So this is the formula of EI function. PRT means that your pressure at a certain radius at certain time equal to initial pressure plus 70.6 Q naught, mu naught, V naught. V naught is oil volume factor divided by K multiplied by H. EI minus 948 porosity, viscosity, total compressibility R square divided by permeability multiplied by T. And this is the explanation if you are not clear enough. It's simple, you just plug in the number and then you are about to finish. You just plug in the number in the equation, it will be given Q naught, B naught, everything will be given, but it's not finished, it's about to finish. You have to calculate the EI. How to calculate the EI? We go to the next slide. So next slide is how to calculate the EI. When you want to find your EI, you have to calculate the X. What is X? X is here, is it coming from here. Actually it's the same thing here, the difference is only the minus. It's same thing. You don't need to memorize this X, you just memorize this all formula, because this formula is include everything to find EI. And then for X less than 0.01, your EI is equal to ln 1.781 multiplied by X. Your X here, your X. Okay, and next is the condition, the second condition, X is between 0.01 10.9. If you got your X between this number, you have to refer to the table that I'll be showing right now. This is your table. Let's say you got your X is 1.7 from your X here. You got your X from here, and you find your X is 1.7. So it's simply your EI function. Your EI minus X is 0. Where is the crucial? 0.07465. So you got your X, you got your EI from your table, and you just change your EI here and multiply by these numbers and plus the initial pressure, and you got your pressure. Lastly, for X higher than 10.9, your EIX simply 0. You don't need to make it so hard. If your X is more than 10.9, it's simply 0. And next is, if you want to calculate the bottom hole pressure, you just use this formula. It's different with the previous formula, but this one is for calculating the bottom hole flowing pressure. And the condition is your R is equal to W. Let's say your R, let's say 0.25, 0.75, 1, 2, 3, 4, 5, 6. So your R, if you want to choose your R is 1. So it's simply your R equal to RW. So you just change your RW into your chosen R here. You don't need to be confused. You just change this into your RW. So you can get your bottom hole pressure or PWF. But with the condition your T is higher than 9.48 and so on. I will give you an example. Let's say estimate the bottom hole flowing pressure after 10 hours of production, and you know your T is 10 hours, and you figure it your T is higher than 9.48 and so on. Your T is higher, and you're allowed to use this formula to calculate the bottom hole flowing pressure. It's simple. You just plug in the number after you figure out your T is higher, and you change the RW, and you just calculate and plug it inside your calculator, and you find your bottom hole flowing pressure. Thank you for your listening. That's all my part. Bye bye.
Hello guys, I'm Chris. So now I'll be giving you an example for EI solutions. The question is, an oil well is producing at a constant flow rate of 300 STP per day under unsteady state flow conditions. The reservoir has the following rock and fluid properties. So these are all the rock and fluid properties that given. They include porosity, permeability, viscosity, radius of bore, and as well as initial pressure. So now the question is asking us to calculate the pressure at different pressures for 24 hours. And then we have to plot the graph of pressure versus logarithm of radius, and as well as the graph of pressure versus pressure. So in order to solve the questions, the example that given, the first step we have to do is substitute all the values that given into a general equation of pressure. This is the general equation of pressures. So we have to substitute all the given values inside to simplify the equation so that it's easier for us to calculate the values that we need later on. So these equations is the equation that in the simplified version include all the values. And then second step is to perform the calculations that shown in the tables. So first we have to obtain the X, and then we can get the EI. After getting the EI, we substitute the EI into the simplified version equation of pressure. Then we can get all the pressures. So in order to get X, we have to use this formula: X equal to 4.266 times 10 to the power of -5 R square over 24. So we have to substitute all the R inside this equation, and we can able to obtain all the X. After getting the X, when we need to get the EI, we have to determine X, whether it's smaller than 0.01 or in between 0.01 to 10 or larger than 10. If the value that we get in X is less than 0.01, like all the X value in the yellow columns, we have to use these equations to obtain the EI. And for example, the X which in between 0.01 to 10, all these values, we can refer to a table that given to us to obtain the EI. And for example, this one is more than 10, so automatically the EI will become 0. So after getting all the EI, we just substitute inside these equations to get all the pressures. These are the two graphs that we draw based on the values that we obtain from P. So as you can see there, this is the pressure versus radius. We have increasing of pressure, and then increasing of pressure according to radius. And this is the graph that based on pressure versus logarithm of radius. Yep. So basically, the steps to solve the question related to EI solutions. First step is to substitute all the values given into the equation of P, and then we have to calculate the X. After that, we need to, based on the value of X, we have to find out the EI. After we getting the EI, then only we can substitute inside the pressure, the equation of pressure, and obtain the pressures. I think that's all for my part. I mean, these are all the steps that you have to remember for the question that related to EI solutions. So I hope every one of you is now clear about what is EI solutions all about, as well as the things have to be reminded in EI solutions. So once again, thank you. We are from Group 5.